I'm Dan Alford, and you're listening to Dan's Cadre of Experts. As you well know, I'm a big fan of professional societies, so we have a representative in here today from ASM, which originally was American Society for Metals. It's now American Society for Materials. Jean-Marc Tetevy, welcome to the show.
Thank you, Dan, for having me. Yes, I'm actually the vice chairman of the Houston chapter of ASM International.
And we asked Abby to join us today because she's a perfect example of what these societies can do, because you're a recent hire here at Arc Specialties. And how did we meet?
I first met Dan through ASM, the student chapter, so it was called Material Advantage. I'm a recent graduate of Texas A&M, so we did an industry visit to find out what engineers do in the real world. So Dan was very generous, very kind. He gave us a walkthrough of the company, got to meet him again at an ASM Houston Professional Society meeting, and got offered a job.
And you turned us down initially because you had
It was a pause.
because you had a fascinating opportunity at Livermore Labs. And
I did. I got to spend the summer in California working with some ceramics, and then got to come back here and learn all about metals.
now we're down to work.
Absolutely.
So ASM is one of the many societies I'm involved in. And so, Jean-Marc, would you just explain what the society does, maybe the history of it,
Yeah, so today it's American Society for Materials. It's actually an international society. I know there's a chapter, independent chapter in India, in Europe, and United States and Canada, of course. Originally, the society was created in the early 1900s as a heat-treated society when the automotive industry was starting to grow up. They realized that there was not a whole lot of knowledge in the heat-treated of steel. And it was all kept by blacksmiths, and it was just, you know, fathers to son type knowledge. So they created that society and that group so that that knowledge started to be spread. So it became later on the American Society for Metals, and somewhere in the 50s it was extended to the American Society for Materials. So today it is a very large resource of data and information about materials, all type of materials. Inside of it, we have sub-society like the heat treating society. But one of the big goals is to educate about the need for more material science, which kind of is the base for a whole lot of other industries.
Got it. So, Abby, back up. Why did you bother to join the ASM at A&M?
With A&M, I really enjoyed their materials science program. I enjoyed a lot of the hands-on research opportunities, a lot of the lab experiences that we got, but a lot of what university life in general had been focused on was the academic side of things, which is fascinating. But I found myself wanting to figure out just what engineers do in the real world, and specifically where material science fits into that niche, because everything is made of materials. I mean,
So,
I don't want
so
my
why
clothes.
choose material science versus mechanical engineering or
It was a lot more specific, and I found actually at first I wanted to go into mechanical. I thought that was what I wanted to do. Did robotics in high school, did a lot of kind of preliminary engineering courses. I thought it was fascinating. But whenever I took chemistry and whenever I took physics, I was like, this is really cool. And it fascinated me in a way that was very different from anything that I had experienced before. So I just found myself diving deeper into that, and that led me to materials. And it's just fascinating that why things are made of the way, or why they're made of what they're made of, and how those materials can be adapted, how they can be reused, recycled, and just what we can accomplish with technology if we only had the right materials. So it was something that I really wanted to see how things were looking in industry, aside from research, how those gaps were being filled, how companies were using that knowledge, gaining that knowledge.
So she mentioned this summer that she worked in ceramics. That's your background too, isn't it?
Yeah, so actually, kind of similarly, I wanted, I think at some point, I wanted to be a mechanical engineer. And eventually, the curriculum in Europe don't work exactly the same way. But I ended up falling in material science and specifically ceramic engineering. So you would think that that can be a little very specific, but then I did some internship with companies that were involved with hard material, tungsten carbide specifically, and then eventually I was sent in the U.S. working for a company and started to do hard facing that involves some of those hard material, but a lot of brazing and welding, and I had to learn welding and learn metals, uh, but with good base in material science, eventually that's giving you some good tools.
Interesting. So nowadays, what all does ASM do? Why should I bother to join?
Well, so professional association in general, yeah. Why bother joining? So it can depend a little bit where you are into your career. When you start out of a graduate or even as an undergraduate, and you want to eventually learn something, access resources and education of things that maybe were not taught in school. Those professional association can be a good tool. They are a great way of networking with like-minded people, let's say. There also a lot of additional education and mentoring. I think is something that I was lucky to get when I was starting in a new country in a new town. Uh, and I think sometimes it's a little hard to realize that you need it because you get out of school and you don't know what you don't know. Uh, but as you progress, I think you realize that that's very useful. And, yeah.
I still have my books from my ASM metallurgy, no, heat treatment of steel class, which I took in 1980.
Oh, so I took three classes. Some of them were not necessarily enlightening, but I also still have some books. I have the oil field metallurgies, metallurgy for non-metallurgists, and I even took a class that was offered at one point that was about surface engineering, thermal spray, and weld overlays.
Abby, what was the event you went to last week? There was an ASM event, wasn't there?
Last week there was the professional meeting, or this past week there was the professional meeting. It was real great. They had a speaker come and talk about the invention of new martensitic stainless steel alloys. It was really cool to just kind of
Do
see.
we have an application?
There's plenty of applications. So we had a gentleman from Carpenter Technology who presented some new stainless steels they have with potential application that are definitely out there in compared to some of the materials that are currently being used. It's true that sometimes we in the metal industry you're still working with alloys that were invented 100 years ago, and now we're talking about technology moving fast, new equipment, new material being needed, but sometimes we're moving at a slow pace with some of those new alloys.
We're starting to work in the small modular nuclear reactor segment, and I think there's a bunch of room for improvement on materials there. I think some of these folks are stuck in the 60s because we have good creep data from way back then, and I'm hoping some of the newer technologies will help enable these SMRs to come online sooner. So I live in fear of being a dinosaur. That's why I'm a member of ASM is trying to keep up with technology. And I get a lot from these technical meetings you have. You know, the monthly meetings are useful. You guys had a great one on additive manufacturing just a couple of years ago. So a lot of timely topics.
Yeah, we're gonna have some more. We have some upcoming meeting on some new brazing technologies, some on additive manufacturing of thin wall component at high speed. So all that combines not just metal and materials, but also automation and computerization to be able to precisely bring material where they need it and with the control microstructures.
Like Dr. Bruce Craig, his comment was, the oil we're finding, we don't have the materials and technology to produce now. So it's exciting. So somebody, young person like Abby, you've got a lot of things ahead of you, a lot of problems to solve. Otherwise, we're going to run out of oil.
This is some of the thing we do as a chapter as well. So we organize a panel discussion between professional and students, some of them being still undergraduate, some of them being involved in doctorate programs, and so on. And very often we got question, and you have students that are already engaged into material science, and they're worried. They're like, "What are we going to do?" And you just answer. I don't think we're running out of idea. And, between taking care of existing and old infrastructure and all the new things that are coming along, I think it's a pretty safe path, and I doubt even things like AI are going to be putting those young engineers out of business anytime soon.
No,
It's been really amazing to see ASM just take such an active role in that. I remember when I was still an undergrad, we had a couple of times a panel of ASM folks drove up to College Station, and it was really generous of them, gave their time for a dinner and a panel, and it was amazing. People from like oil companies, people from companies that make different kinds of alloys, people who were more in the failure analysis business. And it was just great to see that wide variety of experiences from all over. And so everybody was super engaged. A lot of fun questions for, people who are still young engineers figuring out what they want to do and what interests them.
A couple of years ago, we even had a gentleman who had a material science bachelor's, and he was actually also a lawyer, and he was working on IPs. So very, very interesting perspectives there.
So what about the fun side of ASM? Abby, I heard you're on a shotgun team.
I am. I will be learning how to shoot and hopefully be performing well at the ASM clay shoot upcoming in December.
But there's a bigger, other than shooting shotguns, there's a bigger goal, right?
So in this case, it's actually somebody you and I have known then, but we've created a local scholarship in the name of Wayne Quantz.
He was our first consulting metallurgist way back at Arc Specialties. We did a whole lot of the G65, B611 wear test, and I still use the data that Wayne generated.
Yeah, he introduced the industry to a lot of some of those standardized tests that were not being used enough, and everybody was doing their own testing in their corner. And so yes, he did that. He was a chairman several times in a row and was very active in bringing students and his knowledge to the industry and to students. So we created a permanent scholarship in his name, and in order to grow those funds and give away a bigger scholarship, we have that clay shoot event. It's going to be the 6 years in a row that we had it. So now those funds are bringing some decent money. This year, just those funds generated $2,000-3,000 scholarship for
Nice.
undergraduate and graduates, and in total, ASM Houston chapter gave $40,000 worth of scholarship this year.
Which schools?
So far, it's mostly been Texas-based schools. It has to do with the fact that we try to connect with materials science department. We, in the past, have done not only local school like U of H, Rice University, Texas A&M, Le Tourneau occasionally, University of Texas in El Paso, but this year we had some first students from University of North Texas in Denton. They have actually a pretty decent material science department, and I happened to visit them yesterday. They had an open house and invited us out there.
Do you have any applicants for next year?
No, not yet. The new application will be sent out for probably toward the end of the year, and usually the deadline is around early to mid March of 2026. And we have 3 level of scholarship, so 3 group reviewing those applicants, and eventually we select them by May, June, and we try to have some sort of gathering around October where they can all come and get their check.
You just had that a week or two ago.
Last month we had Oktoberfest, mid-October. We had that at St. Arnold Brewery in Houston. So we had a total of 12 recipients, and I think 9 of them showed up, including some from Denton that came to meet other students, which was an interesting thing. We had a few doctors from University of Houston. There was quite a group from Texas A&M.
Chase Katz won one of them, didn't he?
Yes, he's
That's a
won
mutual friend, right?
several years in a row. He's actually extremely active in that material advantage chapter at Texas A&M. And if you check actually what they do through social media like LinkedIn, they're putting quite the program. They have a lot of activities, and they engage with not only local activities, but large companies coming to present technical meetings.
That's amazing stuff. I know Material Advantage, it was hard for a lot of student organizations after COVID. A lot of things shut down. There just weren't a whole lot of things happening in person. So it's been really great to see that student chapter kind of get revived and start doing things again and being more active since COVID. And I think Chase has been a really big part of that.
Yeah, he's a great enthusiast. I credit him with introducing us.
Oh, absolutely.
I remember he actually came. He was one of the few students coming to our monthly technical meeting, and we've been encouraging them to do that. And one day he came with Abby, and he's like, "Hey, Jean-Marc, Abby's going to graduate. She's looking for a job."
Find her a job.
Okay.
The rest is history.
Yep. We generally, when we go to do those panels, we try to also explain that ASM it's a great networking place, but I would say students who are starting should start thinking about building that network on their first day of school, not on the last day of school.
Did you get any ASM scholarships?
I did not.
Did
I
you
was
apply?
graduating too late to apply because I was already a senior by the time that it was really something that I had heard about, unfortunately. So I missed that boat.
Well, see, that's why
It was not the last year. It was the first year we did it. We've had them for 15, 20 years. So yes.
That's why we're having you on the show today. We're talking to the kids that are in school now,
Yes.
and trying to convince them to join. How much did it cost you to join as a student member?
Oh, I want to say membership was around $65, maybe.
What? You don't give away.
I think it's a lot cheaper than that. I think the Materials Advantage is close to $30, and there's
Material Advantage, yes. I know for the first year of ASM Professional, it's a discounted rate, just coming out of being a student.
No, so ASM is about $65 per year, and the first year you get discounted. But Materials Advantage at the university is a lot cheaper, and a lot of departments are actually reimbursing a lot of the students just to join. So it can be, at most universities, close to nothing.
Okay, how do you join?
For us, you can get online. There's ASM International. You can go to their website. It will eventually ask if you want to be affiliated with a local chapter. So if you're in the Houston area, Houston is one of the most active chapter in the country. Probably the largest chapter today is the one in Detroit because of the origin of the society. But Houston is fairly active. We try to encourage other local chapters. There's a chapter in San Antonio and one in North Texas. But we have a lot of activities. We're trying to have a lot of meetings and cater to different materials group.
I know it's in Houston, it's asmhou.org.
It was something like that, asmhou.org. It's that website's still active. We ASM International trying to migrate all the chapters to another website. The URL might not change, but it's going to be a little more convenient and a little bit better to manage. But yes, asmhou.org should get you to our main chapter page.
I'll give you an update on current events.
Current events, so December the 6th, we're going to have actually the clay shoot. So that's one of the good events that helps us. First, it's fun. We're going to have about 20 teams competing in clay shoot.
And you usually have your scholarship recipients as workers in the at the clay shoot, right?
Yes, we need volunteer for the event. We need a spotter for the station, and usually we have not just scholarship recipient, but we have students that have been graceful and are helping us every year.
And in the process, they get to talk to all the metallurgists in Houston and probably meet their next boss.
Well, just like I was mentioning, networking starts as early as you can, and you'll find a lot of professionals who will say, "Hey, what's your name? What you doing? What do you want to do?" And
Are you free this summer?
Yes.
And I think that was one thing that was just so great about ASM was I think it's intimidating as a student going into a professional world and being like, okay, I have to be this, I have to be prepared with this, and you don't know what to expect necessarily, but I was surprised at how just conversational and how easy it was to talk to a lot of the folks there.
Yes. You come in a meeting, nobody's going to be grilling you about steel phases and anything like that.
No, usually when a young person shows up at one of our at a meeting, they're instantly greeted by a bunch of folks. So
Yeah.
it's a very welcoming group. I know one of the things you want to talk about, one of my favorite things about ASM is Teachers Camp. And I didn't know anything about it. And so Teachers Camp, here, I'm going to give you my version, you can correct me, but what you seem to be doing is teaching high school teachers how to teach material science. And this is free for teachers. And so before I wanted to commit any resources to it, I actually went and sat in on one of the classes. It was excellent. The teachers were superb, and they had some cool experiments. They were etching the aluminum cans off of soft drinks and doing all sorts of cool stuff. And so I was in at that point. So ever since I've been supporting the group, and lately what we'll do is after you guys run the teachers camp is you'll send all the teachers over here to ARC Specialties. We buy them pizza, but mostly what we do is we give them a tour and show them what people do with material science, at least in the field of robotics, because robots are made out of copper, steel, aluminum, magnesium, you name a material, we're using it. So it's a perfect place, and it really gives these high school teachers a better view of what the students, should they go into material engineering or engineering in general, might do for a living. And so I think it's a great program, and that's why I'm enjoying working with you guys.
Yeah, so yes, you describe it perfectly. The idea is that, yes, we could go to all the high school and try to access all the kids and try to see who could or might be interested in something related to material science. But we're an association. We're not. We only so many people, so many volunteers. And it's a little smarter approach to go see STEM teachers and say, hey, you're doing the best you can, but come to our camps. We're going to give you tools. We're going to we're gonna show you fun materials related experiment. You're gonna go back with books of those type experiments that are easy
And
to do.
kits. And you're distributing kits, so.
Yes, absolutely. But then there's even further than that. But into that program, we know that if we open their eye and show them fun stuff to do, fun stuff to show the kids, now they might emulate some kids to say, "Hey, material science could be cool," and then get into that field. And what you're doing is great because yes, it's one thing to show them a little experiment, but being able to show them what can be done with material science, with welding, and all of that has some great root, and also show them in a company. It's not just about engineers. There's a lot of people working in a company where that knowledge has application.
So how can a teacher get into this?
Like you said, it's free. We're even trying to make it more than free. We're trying to
Pay them to go to school.
at least pay their way. Sometimes their school district would pay for their stay, for their time. But we're trying to eventually get where we help. There's some other chapters where they have different facilities, and they even have the teachers have a free stay
Excellent.
in an area. We would like to be able to get there. We have a few ideas on new things we're gonna try to bring in order to promote that idea. Maybe create some sort of endowment that will go towards helping those teachers who wants to come. But it's free. You register. Last year we had something like 30 plus teachers who wanted to attend. We ended up having 17, 18 showing up for that few days, almost 1 week course, and then they came to
Then they get free pizza at Arc Specialties.
and they get free pizza at our specialties.
Well, I don't know if you know this, but already 3 of the teachers that you brought me this year have brought their kids back. And so we've done 3 student tours since then. So it's, I think they were convinced because they thought it was cool enough they wanted to bring their kids back, and their kids seemed to enjoy the visit too.
And for the last 2 years, we've done something else to try to complement Teachers Camp, and that is to have like a STEM classroom support. So if STEM teachers come out and say, "Hey, I would like to do something in my classroom, but I'm missing equipment, material. Some wanted to have a little rolling mill to do some of those experiments with metal." And we have given grants around $500 for those teachers.
Excellent.
So they have to apply. Same thing. They apply online. They give us a few lines about, "Hey, this is my project. This is what I would like to do in my classroom," and we elect which one makes sense. And I think last year we gave 6 or 7 of those little grants.
Very cool. So, Abby, you're like the poster child for material science. So, what are you working on at ARC? What has been interesting? I hope you have something interested you here.
Oh yeah, I've been doing a lot of research into just kind of what makes different alloys weldable. For one, started looking into welding Zirc alloy 4 to some different stainless steels. So finding out sort of the feasibility of that, what's been done in the past, how potentially are some ways that could that be done a little bit better. And then one of the more recent projects has been actually alloying some 316 material with other powders to see if you could get the composition of 316H, because the difference between 316L and 316H is mainly the carbon content. So 316L has about a maximum of 0.03 carbon, where 316H has 0.08 to 1% carbon.
And it's actually hard to find 316H, and it's easy to find 316L. Mm-hmm. And a lot of the new small modular reactor guys are wanting to run 316H, and so that's what we're doing, right? Is we're going to allow them to make their own alloys.
Mm-hmm. So still very much in the kind of workshopping process, because we found that we have the carbon content, but it's, do we have the microstructure? Do we have the properties? Does it behave? As well as a alloy specifically manufactured to be 316H wood.
And so what are the tests you're going to do to finish this qualification?
Starting out with some sort of microstructural analysis, so grinding, polishing, looking at what the structure is. A lot of cool microscopes here that we're looking at. For one, that's a start. We've already kind of looked at the chemistry, hoping to look at the chemistry sort of throughout to see what that's like. And then, yeah, just sort of taking next steps from there as we find sort of things that check the box or not, I guess.
So when you don't have in-house the resources and the tool to do that, what are you doing to find them?
That's what ASM is so great
Thank
for.
you.
Whenever there's a professional society like this, it's easy to just show up to a meeting and be like, hey, this is what I'm working on. Do you have any expertise in this area?
Yeah, and usually you always have somebody saying, I don't know, but I know the guy who does. Yeah.
So did you find somebody to do the X-ray diffraction?
There are some people in ASM who have those resources, yes.
Good. That's the one test you didn't mention that I want to see the results from. Yeah, we've got a lot of stuff, and you're saying you want to weld zirconium to stainless, and there's actually papers on this. We're not doing anything that hasn't been done before in some other form or fashion. So it's a combination of both literature research you're doing, and then we actually go to the lab and then try to make it literally stick together.
Like the alloy one, for example, the 316L to 316H, that I had actually sort of done a few calculations where it was like, okay, if I'm starting out with this carbon content and I want this carbon content, theoretically, how much powder should I add instead of just going and being like, oh, well, I'm going to test this amount of powder and then this. So there's, yeah, definitely a very cool aspect of research, and then the practicality of the lab, which is just what brings everything together.
And I must admit I was impressed. I would have just thrown some in and checked the results, but you were a little bit more methodical, and I applaud you for it. But
that was also fun. That was arguably more fun. But
what I thought was interesting is normally when welding, you lose alloys across the arc at different rates depending on the alloy. And we're running this with Slag, which is an older, very interesting and unique process. And you discovered that we had lost no alloys over the arc. So,
yes.
So we're going to expand this, right? Into what other processes, correct?
One thing that we've also been kind of looking at lately has been, okay, if we're going to weld in a bunch of these different ways, so you have TIG, you have MIG, you have submerged arc, for example, and so just how does the composition of your final weld change if we start out with the same wire composition? How is that changing depending on the process? So yeah, also something we're looking a little bit more into, and it'll be really cool to see what we can kind of find.
So you're trying to do what a lot of people who actually manufacture cold wire for welding are doing. It's like cooking a recipe to try to bring in the sauce, everything that they need. But yes, there's a way to bring that eventually after and not have to rely on a supplier manufacturing tons of a product so that you can do your experiment.
But the difference between us and them is you're going to publish this, right? Because if you do publish this, I would read that article, because it definitely surprised me when we didn't have any alloy across the arc and Slag. So I just brought all this up to see if somebody out there in the audience might be as intrigued as we are with this whole science of material science. It's a whole lot of fun. You learn a lot of stuff. You build on the past, but you take it beyond where you find it.
Absolutely, and I think that's been one of the great things about what I've experienced so far about working at ARC is there's a lot that I kind of knew from material science and just from that background, but there's also so much that I didn't know. For example, like welding terminology, things that are completely new. So whenever people start talking, it's like, oh, what? But it's been great to just kind of pick up on things and be like, oh, okay, like hearing somebody talk about this and being like, oh, okay, this is the materials tie-in. That's something that I learned from one of my classes. So it's just been awesome to see that intersection kind of working in a company.
And then you walk out in the lab and do it. There's nothing beats empirical data.
No, and when I started, it's been a minute, but I had two types of people that I ran into. Unfortunately, there were a few people who you were like, hey, you seem to be an expert about that, and I wasn't shy. Show me what you know. And I had some who told me, no, I learned the hard way. You're gonna have to do the same way.
What?
And then I had guys, and Dan is one of them. I say, hey, show me what you know about this, and he showed me a whole lot more than what I wanted, but it was fun, and I learned a lot of things. So I think you found a good spot. In general, whether it's in our association and other, I found that there's a lot of people who are willing to mentor and to help, not just young graduates, but they want to help. But sometimes it's just about asking them, and that's a good way to put all those together.
But you must be present to win.
Yes.
So I was impressed that you joined ASM. So anybody out there, I guess we're talking to professionals. We're suggesting that ASM might be a good society to join. And do you have to join to come to the first meeting, Jean-Marc?
No, you can join any of our meeting as non-members. We sometimes have a little bit of preferential treatment and access for members, but you can access any of our meeting whether you're a member or not. You can access any of our metallurgy class whether you're a member or not.
And then students need to join for the networking and for the scholarships.
Yes.
And for the publications and the opportunities.
Yes, there's a lot of publications. There's a lot of material science journals. Some can be very specialized. There's some handbooks on metallurgy, sample preparation. There's also some libraries of books you have to pay for, but there's a lot of data and resources that are free access when you're a member.
And high school.
Oops, sorry. Just one thing I also remember from signing up from Material Advantage whenever I was still in school was actually with the ASM membership, we also got access to some of the other materials societies. So, for example, the American Ceramics Society. Yeah. So I'll still get emails where it's different publications that have come out, different notifications.
So the
really
Materials
cool.
Advantage itself is I think is a group of 3 societies together. So those students they join that Materials Advantage, and they have access to the American Ceramic Societies, ASM International. And what is the last one? Is it, that's not the chemical engineering, it's something else.
I want to say it was one with polymers.
Okay.
But definitely look into it as a student, get good benefits as a student. It's like that little package deal.
And the third thing is, what level teachers? These high school teachers you teaching, or?
Typically, but it's not, it can be middle school and high school.
Okay. So any teacher that's interested in this teacher camp, and I tell you, I thoroughly enjoyed it. I've been doing this my whole career, and I learned stuff in that class. So
yes, I did too. I mean, there's this fun experiment. All the experiments what they do with the cornstarch are easy to do and can be fun. They got videos that you can access with people who put cornstarch in whole swimming pool and walking across them. I mean, you see that, you're like, oh, I want to be a kid again.
So Johnny will put some links on there, whatever you suggest for people to access all this stuff. Once again, that's why we're doing this podcast. I'm such a big fan of professional societies in general and ASM specifically. What did we miss?
Not a whole lot, but I do have a question for you too, because I know
whose interview is this?
Well, sorry, I know what drives me sometimes, but I'd like to know what drives you, because yes, you've helped with teachers camp and you're always helping, but you've been doing helping kids with robot competition and every time there's somebody who's in town and say, hey, I'm a teacher, I'm a student, I'm interested in this, your door's always open. So why do you do it?
I've had such a good career. I've had so much fun. I've gotten to work in 33 countries. I've gotten to meet so many good people, and so I'm eager to give back. And I believe that all there is in the world is people. My wife says I have a problem never saying no. So you combine all that, and I like people, I like kids, and I'm happy to give back. And what you'll find is you'll get more in return. We were hosting an event for you, and I ended up with my most recent material science employee. So that's what drives it. Nowadays, what fires me up is creating jobs.
Yeah, that makes sense. Yeah, so in general, I'm thinking, hey, I was lucky. I met great people. I've traveled a lot. I've worked with different industry, different countries, and um, yeah, paying back, leaving the place better than you found it. I think it's good principle.
Yeah.
What motivates you?
Leaving school, I think it's kind of an interesting situation because you've spent kind of all of this time preparing for college, all throughout high school, and once you're in, trying to build experience, trying to build a good resume. And so I think it's really easy at the end of it to be like, okay, well, I graduated, I'm done. But that's not what I want to do. I mean, I want to keep learning. And yeah, just things that I've very much learned here is just know, like, the learning, not only does it not stop, like, it cannot stop if I'm going to be successful in any way. So just, yeah, I want to know things. I want to know why things work the way that they do.
It cannot, you can't stop learning, and I would say, yeah, there's a lot of people who are going to talk about the good old time, but science, material science today is not what it was 50 years ago. There's so much different alloys, different process. There is no way you can spend your life learning all of it. So being involved, learning what you can, but also knowing who's your friend and who can help you when you want to use something that you don't have the knowledge in. Is I think that's what those society are good for.
Yeah, during the week, you and I are competitors,
Sometimes, yes.
and then but when it comes to ASM, we're collaborators.
And you're going to find a lot of that. You got people selling metals. You have people, 4 or 5 competitors selling steel, selling nickels. But when they go there, they know that there's also argument for them to visit and to go there and improving the network and improving the knowledge out there will help all of them, maybe the competitor, but them to get somewhere.
I've had a great career in this field. I'm on Medicare now. You've had a great career, and I'm glad to see there's people like Abby that are out there that are looking forward to doing this. I think the challenges ahead of you are just going to be so much fun. Back when
Absolutely.
when I started, you could use a single material. That's no longer viable. You're going to have to be combining properties by combining materials, and I think it's going to be fascinating.
Yeah. New thing like what you're doing, the microalloying, maybe even creating a single component with more than one alloy in it. That's doable today, and that's going to be very interesting to create new technology and new equipment.
Well, guys, thanks for coming on today. Maybe we ought to do this on an annual basis or something, but that was a lot of fun. I enjoyed the conversation.
Thank you.
Thanks.